How are you, everyone? My name is Mr. J.M. Kimani, your lecturer in quantitative analysis. Welcome to sample paper 1 of time series. Now, sample paper 1, the question reads that the table below shows the sales of new cars by quarters during a period of 3 years. You're given the year column, the quarter 1, shillings in millions, quarter 2, shillings in millions, quarter 3, shillings in millions, quarter 4, shillings in millions. 2014, 55, 76, 61, 77, respectively. 2015, 54, 65, 52, 81, respectively. 2016, 59, 83, 78, 93, respectively. Required. 1. Seasonal indices using the moving average method. Number 2. Deseasonalized sales. Number 3. Using the deseasonalized sales above, fit a regression line using the least squares method. And number 4, forecast the seasonally adjusted sales for each quarter in 2017 using the regression line in 3 above. End of question. Now, when talk of time series, then that should remind us of the components and also the models. Having the components where we have the secular trend, we have the seasonal variation, we have the cyclical variation, and we have the irregular variation, where this is residual variation. Talking of the models, we have the additive and you have the multiplicative. Now we can determine all these using the additive model and also the multiplicative model. But in most cases, multiplicative is most applicable, as additive may not be in most cases. So the sales of the second quarter may have an effect, a multiplicative effect from the first quarter than it has in terms of additive effect. So that is why we normally use the multiplicative effect. Now, when we say that y equals to t times s times r, if r is held constant, that what is able to be explained is trend and season, then now we say y equals to t times s. Should we want to get the trend, then we say that it is y divided by s. Should we want to get the seasonal variation, we say that y we divide by t, as you can see from this equation. So this is our function or our model. So should we want to get any of these, then we just make them the subject and we're able to determine that trend or that the season. So this is where is how we get the seasonal or the seasonal indices, and this is how we can get our deseasonalized sales, where we remove the seasonal effect from our original data. That is how it is. But if it is the additive model, so we say that y equals to t plus s plus r, that if this is constant, then y equals to t plus s. Should we want to get the trend, we can get the y minus s. Should we want to get the season, we can get y minus t. That's how. So we are going to use this one in our question multiplicative model, and then see how all these involved. We have the methods of getting trend, to get the trend analysis. So we can either use the moving average, or we use the regression. Now, I've asked we use the moving average to fit the trend. Then now later, we use the regression to do the forecasting. That is what I want, so that at least we'll have revised the moving average and the trend. The regression, moving average and the regression. So that is what. So we need to arrange our data so that we're able to have all these columns in place. And we are going to have these being our actual sales. So first of all, we have the year. We have the actual sales, which is our Y. Before actual sales, we have the quarters. Remembered? We have quarters, which is our T. We have the sales. This is actual sales, which is our Y. We do have the 4-month or 4 moving average, because we have 4 quarters. We have the centering of moving average, which is our trend. Then we have because we are using the multiplicative model, we are going to have Y over T, which is the seasonal indices, but we are going to adjust them so that you can have the seasonal indices here. Then later you can have Y divided by S. This is SI. Then from there, we can have our, this is T squared, and Y, this is T Y, and you have T squared. But this TY, it is this decisionalized one. So we can have this as our, if I put Y over FSI over SI, so this is going to be our YT. So that way. So if I have these columns with me, then I'm able to determine all the values required. So we do have the years, the year 2014. This is 2014. We have quarter 1, 2, 3, 4. 2015, quarter 1, 2, 3, 4. 2016, quarter 1, 2, 3, 4. But at the same time, because of regression, remember, if you're going to use moving average only, then you can have 1, 2, 3, 4, 1, 2, 3, 4. But if you're going to use regression, then you need to use the trend, or these quarters or time on a continuous basis. So meaning, I am going to change. Now I have continuation. So after 4, I just proceed to 5, 6, 7, 8. Then this is going to be 9, 10, 11, 12. So this is what you're going to have. So this is 2016, the year. And this is 2015, the year. 2015, that way. Then we have our actual values, which have been given there as, we have 55, 76, 61, 77, 54, 65, 52, 81, 59, 83, 78, 93. So that is our data. Now, When we start fitting the trend using the moving average, so we are going to have 4-month moving average or 4 quarters. So 4-quarter moving average, we are going to be adding the 4, then we take the average of the 4. That average, we are going to put it under the mid of these quarters. So we are going to have this way. So we are going to be having the mid. So like now, if you take the first 4 quarters, the mid of the first quarters is between 2 and 3. So we'll be having our value here. So we'll be having our values there. And these values will not be corresponding to the specific quarters. These values will be in between the quarters. So that now we can indicate that 55 plus 76 plus 61 plus 77. I divide by 4. My answer is going to be 67.25. This is a 67.25. The next one is 76 plus 61 plus 77 plus 54. This is divided by 4, giving 67. The next one is 61 plus 77 plus 54 plus 65. 65. And then you divide by 4. This is 64.25. The next one, if you get confused, so where you reached and where you're starting, so you just look at where you want to indicate, then you count 2 up and 2 down. So like now, if I want to record here, I count 54, I add 77, and I add 65 and 52. Then divide by 4. I get 62 here. Then this one, I'll count 54 and 65. 54 plus 65, then plus 52 plus 81. Then divide by 4. This is 63. Then here I'll count 65 plus 52 plus 81 plus 59. Then divide by 4. This will be 64.25. Then this I'll count 52 plus 81 plus 59 plus 83. This I divide by 4 will give me 68.75. Then this one I'll count 81 plus 59 plus 83 plus 78. Divide by 4. This will give me 75.25. And finally, this one I'll take 59 plus 83 plus 78 plus 93. I divide by 4. This will give me 78.25. So these are the values we have as far as the quarters are concerned. And because of the values not corresponding with any particular quarter, so we now need to center. This is centering of moving average. So which is going to be our trend. That the in between these 67 and 60. 67.25 and 67, I'm going to record now my new value here. So I'll be recording my new values. So corresponding, these are new values that are corresponding. So new values that are corresponding that way. So I'll be having, this is a 67.25 plus 67. Then I divide by 2. This now will be 67.125. This is 67 plus 64.25. Divide by 2. This is 65.625. 64.25 plus 62. This is 126.25. Then you have the 62 plus 63. Divide by 2 is 62.5. The 63 plus 64.25. Divide by 2. This is 63.625. Then you have the 64.25 plus 68.75. Then I divide this by 2. I get 66.5. Then the 68.75 plus 75.25. I divide this by 2. I get my 72.0. Then I'm having the 75.25 plus 78.25. Then I divide by 2. This I get the 76.75. And that means that quarter 1, we don't have any, and quarter 2. This is quarter 1, this quarter 2, we don't have any. Quarter 11, you don't have, and quarter 12, you don't have. So that is it. Now, to get the seasonal variation, the effect, because without the season, this should have been the trend is 67, while the total is 61. To know the effect of the season, then you just need to divide this 61 divided by 67. First of all, we don't have any value here. We don't have any value here. So we just need to take the 61, you divide by the 67.125, which is going to give us 0.909 in the decimal places. Then that tells you that the effect of the season is to reduce our sales to 90.9%. That's the effect. Otherwise, if there's no effect, then it would have been 67 instead of 61. Then 77 divided by 65.625. This will give us 1.173. 1.173. Then you have 54. And this one means the effect of the season is to increase our sales to 117.3%. That's why it is higher than it is without the season. So 54 divided by 126.25. This is giving us 0.428. 65 divided by 62.5. This is 1.04. 52 divided by 63.625. This is a 0.817. The 81 divided by 66.5. This is giving us 1.218. 59 divided by 72. This is 0.819. Then you have the 83 divided by 76.75. This is 1.081. Then the rest dash dash. So these are the seasonal variation, but if they are not harmonized and give us an effect of 1 or effect of 1, you know, this season has understated, this one has overstated. So because of the under and overstatement, we would expect that by the end of the 4 seasons, there is no overflow from an year. So if you are having an overflow in quarter 2, assuming we should be having an opposite of that in the following quarter. So within the 4 quarters, like now in this 2015, these 4 quarters here, we are having some overflow, but you're having the compensation. So you do not expect here that we have any overflow beyond that year. So because of that, we may want to do some revision of this season. And I would want to revise it here. Let me revise it here. So this is adjusting. This is a seasonal indices. So we do have the year. We have the quarter 1, 2, 3, 4. That you have the year 2014, 2015, and 2016. 2014, we have quarter 1 and 2, we don't have any seasonal indices, but we do have 0.909 and 1.173. Then you have the 0.428, 1.04, 0.817, 1.218, 0.819, and 1.081 dash in the other quarters. So you can have here the average. So let's see the average. The average means you add and you divide. If there are 2 representation, add and divide them. So this is going to be 0.428. You add 0.819, then divide by 2. This is going to be 0.62. This is 3.5. Then you have 1.04 plus 1.081. This is divided by 2. This is 1.0605. 0.909 plus 0.817. Then divide by 2. This is 0.863. Then 1.173 plus 1.218. Then divide by 2. This is 1.1955. That if you add this now, plus 0.863 plus 1.0605, so we are having 1.0605 plus 0.625. No, 6235. So this is giving us actually 3.7425. We want to make it 4 because it shows that in a particular year we are having some understatement. It is because it's like saying that if this is an overflow, but this one is compensation, but this compensation is higher than the overflow, and therefore we are having some understatement. So we need to make it 4 because if, for example, a particular year, if the sales is, let's say, 80, this is one in one quarter. In the next quarter, if there is no any seasonal adjustment or seasonal indices, then we expect it to be 80 also. Meaning the seasonal index there is 1. So if we are going to have it as 1 point, 1 point, then our sales will be more than 80. If you're having 0 point, then our actual, or the sales in the next quarter shall be less than 80. But if there is no effect of season, it shall be 80, meaning it is 1. So if we have 1, we should have the compensation here. This also compensates. But now in our case, if we are having more, less than 4, so we need to adjust it this way. Seasonal index shall be now 4 divided by 3.7425. So that you can have our seasonal index. So you're going to have here 4 divided by this solution of 3 points, so that you can now multiply 0.6235. 0.6235. This one we can have it as 0.6664. Then we can also have 1.0605. We have it as 0.70. This has decreased instead of increasing. It was 4 divided by 3.74, 3.7425. You multiply the 1.0605 is 1 point here exactly. So this is 1.1335. Then we have 0.863. This is 0.9224. And you're having the other one is 1.1955. This is 1.277777. That way. That's what you have. And indeed, when you add these now become 4. And that's what we want. So we have determined our seasonal indices. Seasonal indices that now we can present them. And this one was now the first requirement, Roman 1. This was Roman 1. So once we have them, what do? We take them here. So every quarter 1 will be having 0 point. 0 point. Let me indicate using a different pen. We'll be having 0.6664. So this is 0.6664. This is 1.1335. This is 0.9224 and 1.27. 1.2777 exactly. Now then we repeat. This is 0.6664, 1.1335, 0.9224, then 1.2777, 0.6664, 1.1335, 0.66, this is 9, 0.9224, then you have 1.2777, exactly. Now with that now we can be able to deseasonalize our data. When we deseasonalize, we remove the effect of season. We are going to get back now our trend, but having adjusted these seasons. We just going back here, but after having adjusted. Like now you see this one was 0.4, but now we have adjusted upward. This also upward, so we can now get our trend this way. So we can have 55, which is why we divide by SI. So 55 divided by 0.66664. So this is going to give us, this is 2.5. The other one is 76 divided by 1.1335. This is 67.0. The next one is 61 divided by 0.9224. This is 66.1. The other one is 77 divided by 1.2777. This is 60.3. This is 54 divided by 0.6664. This is 81.0. 65 divided by 1.1335. This is 57.3. The other one is 52 divided by 0.9224. This is 56.4. The other one is 81 divided by 1.2777. This is 63.4. 59 divided by 0.6664. This is 88.5. 83 divided by 1.1335. This gives us 73.2. 78 divided by 0.9224. 9224. This is 84.6. And lastly, 93 divided by 1.2777. This is 72.8. So this is our deseasonalized data that has no effect of the season. And therefore, as we are going back, how we got 62. So you see, even this one is now lesser because we have adjusted this upwards, and therefore we are having our value adjusted. So anyway, this is how we get our deseasonalized. Therefore, this is actually our second requirement. Then our third requirement is coming up with the regression. And regression, we can do it this way. Regression, that y equals to, so this is yt equals to a plus b t, where we can have b equals to summation of, this is not summation, but first of all, n. This is n summation t y minus summation t summation y. You divide this one by n summation t squared minus summation t square. Then this is a is summation of y minus b summation of t. You divide by n. You can have that. So we can have our data as follows, and we can add, we can store, we can use the memory. So shift clear memory. So we'll be having, this is ty. We have our column t and have our column ty, as in yt. So we can have the total. So this is going to be 1 times, this is 1 times 82.5. We can store the memory. This is actually 82.5. 2 times 67 m plus, this is 134. 3 times 66.1 m plus, this is 198.3. We have 4 times 60.1 56.3 m plus, this is 241.2. We have 5 times 81 m plus, this is 405. There is 6 times 57.3, this is m plus is 343.8. There is 52, not 52 but 7, sorry, 7 times 56.4 m plus, this is 394.8. There is 8 multiplied by 63.4, this one m plus is 507.2. There is 9 times 88.5 m plus, this is 796.5. There is 10 multiplied by 73.2 m plus, this is 732. There is 11 multiplied by 84.6 m plus, this is 930.6. And there is the 12 multiplied by the 72.8 m plus, this is the 873.6. So that now, should we want to determine the total, we recall memory, this is 5,639.5. So you do want to also add the y, this will be 82.5 plus 67 plus 66.1 plus 60.3 plus 81 plus 57.3 plus 56.4 plus 63.4 plus 88.5 plus 73.2 plus 84.6 plus 72.8. This is giving us 853.1. Then t squared is just 1 up to 12 squared. So 1 squared is 1, 2 is 4, 3 is 9, 4 is 16, 5 is 25, 6 is 36, 7 is 49, 8 is 64, 9 is 81, 11 is 120, no, 10 is 100, 11 is 121, and 12 is 144. Should we want to add this? We have 5 plus 9 plus 16 plus 25 plus 36 plus 49 plus 49, 64 plus 81 plus 100 plus 121 plus 144. This is 650. And then t. Should you want to add t? So you have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12. This should be 78. Now, we have everything. If I substitute now here, that I'm having, n is counting them, they are 12. If I'm having 12 in bracket, ty I'm having 5639.5 minus t is 78 and y is 853.1. Then I divide this by 12 multiplied by t squared, which is 650, and then minus 78 squared. So this should give us, so 12 multiplied by 5639 0.5. Then I subtract 78 times 853.1. I divide by 12 times 650 minus 78 squared. This will give us 0. This is 66. Then the other one is A shall be summation of y is actually 853.1 minus 0.66 multiplied by 78. Then you divide this one by 12. So this is actually 853.1 minus 0.66 times 78. Then all this you divide by 12. This coming to 66.8. 66.8. So finally, our yt is given by 66.8 plus 0.66t. And this is now going to be our regression equation. Now, it is this regression equation that we are supposed to substitute the next year, 2017, and 2017, quarter 1, 2, 3, and 4. So you can have here the forecast. This is for 2017. We have the quarter 1, 2, 3, 4. So what we get, first of all, let me indicate here clearly, we'll get what we call the deseasonalized data, then we adjust the season. So this is deseasonalized sales. So which will give us, this is quarters. We'll have 1, 2, 3, and 4. Then you're going to have here the seasonally adjusted. So if this is our quarter 1, 2, 3, 4, we have our seasonal variation SI. Then you have our seasonally adjusted sales. So this is quarter 1, 2, 3, 4. Now let's see. I am having the equation there as 66.8 plus 0.66. I multiply by now the trend, the time after the year 2016, which is 12. I go to the next year, which is now 13. So in fact, let me indicate here is 13. Let me indicate here 14. Indicate here 15 and indicate 16, so that at least you see how I'm substituting. So if I multiply by 13, this I'll get, this is 75.38. Then if I substitute 14, I'll get 76.04. If I substitute 15, I get 76.7, and if I indicate 16, I'll get 77.36. But now remember, these have no seasons. This one not affected by seasons. But now, because the truth is that we need to have them affected by seasons, so we are going to multiply them with the seasonal index. So like now, I'll have the quarter 1 of this year 2017, I'll have it as 75.38. I multiply by the season, which is 0.6664. This is 76.04. I multiply by the season index, 1.1335. This is 76.04. 7, I multiply by 0.9224, and then I have the 77.36, I multiply by 1.2777. So our seasonally adjusted sales of cars shall be as follows: 75.38. This you multiply by 0.6664. So this is going to give us actually 50.2 cars. The next one is 76.04. I multiply by 1.1335. This shall give me 86.2 cars. Then 76.7 multiplied by 0.9224. This is giving me 70.7 cars. And then you have 77.36 multiplied by 1.2777. This is giving me 98.8 cars. So these now are the ones that are affected by the seasons, and I say that they are the ones which now make sense because we cannot avoid, we cannot dispense with the seasonal effects. We must be having the seasonal variations affecting our sales. So without the season, then this would have been the trend. But with the season, then this is how things are. And you can see the effect of the season, that it is actually to increase or to decrease. Like now, this one is to decrease, this to increase because it's already more than one. And that's how it is as far as the forecast is concerned. So we have actually discussed about the multiplicative effect concerning the moving average to get the trend, getting the seasonal indices, adjusting the seasonal indices here to harmonize and make sure it's coming to 4. Then to deseasonalize my data or our sales, and finally to use the forecast. In fact, this forecasting using the deseasonalized sales is the best forecast than forecasting using these actual sales. So the best forecast is removing the seasons, then you forecast as far as the trend is concerned, then you bring back your season as we have done here. And that is how time series and forecasting is done. That's all about our requirements from number 1 to number 4. And for now, that is it. Please do more practice. And this is not a big problem. It is easy. If you follow exactly what I'm doing here, then things are not going to be bad. They're going to be as good and as easy as they appear as I am doing them on the board. Thank you and welcome again.